Hi, I'm Andrew, the Paisley robot guy, and in this video we'll be calibrating the minor deviations and the major deviations of our HD camera module. So here's the robot, it's in the off position, and I'm going to delicately remove the cover of the HD camera module. And then I'm going to turn it on and we'll watch it boot up. And once the robot has booted up, the servos will change position, and I will explain why that is. So I'll turn the robot on, and it's booting up. Now this video also borrows from the RC hobbyist world with the RC servo motors. So this is a servo motor tester, right? This device here, the servo. This is a servo, and it's got a plastic piece on it, and it will plug into this side of the tester, and these batteries will plug into the other side of the tester. So while we're waiting for the robot to boot up, I'm going to connect these devices. So the servo motor goes here, and so the robot has just booted up, and the cameras have moved, and I'll explain what that is in a second. But first we'll go back to this servo. So on this side, there is an S for signal, plus and a minus. The yellow cable is the signal cable that goes to the servo. Servo motors have positions, and they're told to go to these positions and hold them. And this battery pack goes to the other side. There's a plus and a minus pin here, and the red cable is the positive side, and the black one is the negative. So that will go in here, and this turns on our device. So here's our servo motor tester, and there's a button here that you can't see. So there's an LED up here that indicates the mode that the servo tester is in. So here, if this was an RC model, we could move this knob around and it changes the servo position. Pretty cool, huh? So I'm gonna press this button and it moves it there. I press this one and this tests the range of the servo motor. So I'm gonna put it here, change it to this extreme most position, and then I'm going to press the button again, and this white piece of plastic on the servo motor will move. There. What that does is it zeroes the servo motor. So the servo motor is at its zeromost position, and what happens when the robot gets turned on and the motors move is that's when the motors zero themselves into the zeromost position. The robot zeroes those servo motors. So the next thing to do is to log into our robot and start the software calibration for the minor deviation. Now, if I was to do this again, I would have zeroed the servo motors first, and you'll see why in a second here. So you can see my nice Windows desktop. That's a nice background of it here. Now, Hiwonder, when you log into the robot, they want you to use a tool called Real VNC. That tool costs money. The last time I used it, and I'm not saying there's anything bad about Real VNC, it's just that it costs money. So if you're on a budget like me, the best thing to do is to use Ultra VNC. So what I'm going to do now is I'm connecting to the Wi-Fi hotspot that the robot is broadcasting, and it's of the form HW- and alphanumeric combination. I'm doing that off screen because as I'm doing that, other Wi-Fi hotspots are broadcast, and I just, doing this for privacy reasons. So here is the viewer, the VNC viewer, right? And there are a couple of options to use. There's direct and repeater. So we'll use direct, and by default, the IP address of the Hiwonder Raspberry Pi image is this IP address, 192.168.149.1. And under options, we'll leave them as their default options. So I'm going to click connect, and a few windows come up. So there's this one, invalid certificate, and an additional status. So the certificate is saying it's invalid because my computer does not have the certificate on it. It's the first time connecting. So I could view it, but since I know that I'm connecting to the robot, I'm just going to click OK. So this is a Raspberry Pi 5. So the username is Pi. Now, if you had a Raspberry Pi 4, the username would also be Pi. If you Raspberry Pi 4, the password is Raspberry, but I have a Raspberry Pi 5, so the default password is Raspberry Pi. All one word, all lowercase. All lowercase in both instances of the Raspberry Pi 4 or the Raspberry Pi 5. Oh, excuse me. I'm running two screens at the moment. It seems as though sometimes it's a little bit flaky here. It seems as though my Ultra VNC session has terminated itself, so I'm going to run it again. Username Pi, password Raspberry Pi. I'm entering these credentials on the other screen. You can't see it. I'm sorry. Okay. So now it has authenticated again. I don't know. It seems like that's a glitch. So this is the desktop. This is the login. So this black cursor here shows that I'm currently logged into the Raspberry Pi. That's the mouse. So that's where it is. Now you'll see there are multiple icons here. So this is actually a flavor of Linux that's running, and Hiwonder modified the basic Raspberry Pi Linux image, and they put their tools on it. So let's have some fun with the command line. So here's this icon called Terminator. It's actually pretty fun. It's basically just a terminal. So I'm going to double click on that Terminator. It's a terminal. All right. I want to see that. The language is Chinese. Hiwonder is a Chinese company. And here's a very quick crash course in Linux. So I'll run the ls command, and that shows me what files are in this directory. In fact, we could also have more fun. Let's run this command, pwd, print working directory. It shows where we're currently located in the terminal. Right? If you use Linux and you get good at Linux, you have to know these basic commands. So I'm going to run the ls command again, and we can see where we are. Where we want to go is the software directory. So we type in cd, stands for change directory, and I'll type in software. Now, do you see how it comes in as software? I'm going to press the tab key, and that does an autocomplete, and I'll press the enter command. Now, some people, maybe you grew up on MS-DOS. It's somewhat similar. So I'm going to go to run the camera first. Let's go into the lab tool directory, cd lab tool. Yep. Use tab complete, press tab. Apparently there are two directories that have lab in them. So when you press tab, it shows the two of them because it gets confused. So we'll go in the lab tool, ls, and there is a main.py. So there's a Python program here. So /main.py, and that should execute it. So I'll press the enter key. It's pulling up the program. So this is the lab tool program. I'm going to click connect. There. So now you can see two screens, and this is actually the live feed of the camera. We'll get to the one on the left in later videos. And the one on the right is actually the feed from the camera. So it's seeing my recording gantry. I'm going to put my hand over it. You can see that? You see that's my hand over the camera. That's the live feed coming from the camera, right? Now I'm going to take this lab tool and put it up and off to the side. And we can see the live feed coming from the camera. And I'm going to open up another terminal. We want to run another program. So run the ls command. We'll go into the software directory. Let's see what's here. Now we'll go into the servo upper computer directory. cd servo upper computer. Press the enter key. Run the ls command. Okay, so now we're in it. Those are all of the files here. What we need to do is run the main.py directory. So /main.py. Press the enter key. Now it's running. Okay, so here's what we can see. We can see various servo offsets. I'll put this up in the corner. So we have various servo offsets, right? So if a servo 1 represents the up and down motion of the camera. So I move it this way, camera moves in one direction. Move it this way, camera moves in the opposite direction. So move it in various directions. And then turning the camera left and right, that's the servo 2 offset. So turn it this way, moves in that direction. Turn it this way, moves in the opposite direction. Now, servo 3, there is no servo 3 and there is no servo 4, so we can move these sliders and there's no effect on the camera movement. Servo 4 offset has no effect on the camera movement. Now this is to calibrate the minor deviation, but as we can see, if we move these servos, right, I'm going to move this slider, it's the calibration is out of the range of the servo. So this is all the way at the end, and this camera is supposed to be here. It's supposed to be facing straight ahead. And then this servo 2 offset, we move it. What should happen is that we'd like this to be over here. We'd like it to be, I'm going to take a triangle. We'd like it to be at right angles, right? We'd like it to be, right? We would like it to be here, but we can't. So we can't use the software to calibrate the small deviation. So what I'm going to do is turn off the robot and then calibrate the servo motors. But before I do this, I'm going to set the center position to reset. There. The servos are now reset. They're all zeroed. So what this means, I can take apart this assembly and reassemble it with the servos in their zero position. But before I do that, I need to log out of the robot cleanly. So we'll click the X button on the servo offset control. Press exit. Type in exit into the terminal to cleanly exit that instance of the terminal. Here's our lab tool. Disconnect. Disconnected. Press the X button. Quit. Yes. Let's check a look at our terminal here. Okay. So type in the exit command and then press enter. That exits it. And now we'll close Ultra V and C. So Ultra V and C is closed and I've cleanly logged out of the robot. So now I'm going to press the button and turn it off. It's off. And I'm going to put this lens cap back on because I don't want to get a fingerprint on that camera while I manipulate it. So I'll move my chair here. So I'm going to scooch this robot closer. So a few things need to be done. I want to very carefully disconnect this cable. Okay. Those are some very delicate wires in that cable. And while it's here, I'm going to I'm going to very carefully remove this. Take this screw out. Remove it. And for safekeeping, I've got this plastic bag. I could use a cup or I could use a plastic bag. I just so happen to have a plastic bag. I'll put the screw in there, into that plastic bag. And the next thing to do is to very carefully. So there's this rivet. Let's see. So there's a screw on this side, and there's a rivet here. So the best thing to do is to take a flat piece and push up against this rivet. So here, let me show you. So here's the rivet, right? Now, when I do it, you won't be able to see me do it just because of how I have to manipulate this rivet. So this side will, this will pop out slightly after I push this. You can see this slight protrusion. It's kind of difficult to see because it's a black rivet on black anodized aluminum, but I'm going to push on that, and then it'll pop out this one side. So I'll take my pliers in here, pushing. Actually, I'm going to have to use a bigger pair. I'm sure the audience at home is laughing at me. Pushed out. Okay, you see this? Again, it may be difficult to see because this is a black rivet against black anodized aluminum. But you see now there is a space here, right? There's a space. So I'm going to very carefully, I can use either my thin pliers or one of these tweezers. So I'm going to get a very tweezers, nice and thin. Get some traction on that. Hold this and pull it out. So I've pulled out that rivet. And that's part of it. Hang on. It still seems to be in there. I'm going to push it out some more. And take this part of it. And I'm sure all of you at home are laughing. It's kind of delicate here. I got to use the hand-eye coordinations. Okay. Pulled it out. All right, so there are two pieces to this rivet, and I'll put these two pieces in. And I'll put that in my trusty bag because we'll use that for later. So the bag is there with my parts. All right, first things first, forward calibration. So put this up and put this down and put that in there. And I'm going to take this piece out. All right, that way I can get the screw in there. Now this is, let's see here. So while I'm here, I'm going to take my triangle and see if it says, okay, so this is about as orthogonal or straight as normal, as normal I can get this piece with the front of the frame. I'm sure the software calibration will take care of the rest. So now it's time to put the screw in. Take my rivet, put it back in my bag, and then I will take my screw and screw in the U bracket. Use my magnetic screwdriver. Put it in here and screw that down. Let's see, make sure it catches. Just gonna make sure. Remember, it's a self-tapping screw, and that's why I wish I had been able to zero these servos earlier, right? Because self-tapping screws, you really only want to use them once. Okay, now that's in there. This camera servo is zeroed, so I will slightly, push this off to the side, this white piece, so that I can get the servo in there, the part of the axle. Okay, now before I pop the rivet in, let's make sure this is, See, that's not quite where it needs to be. So I'll take this out. A little more of an adjustment. Okay, that is not the best, but I'm sure that it will, the software-based calibration will be good for it. So I will get my rivet here. So I could reuse this one, but Hiwonder has a kit, gives multiple rivets. So I have a bag with more rivets. I'll use a fresh one. And line this up and push it in. Oh, I'm sure the audience at home is laughing at me. Okay, so that will go in there. Push that in. So that's in. All right. So I'll put the robot back here and up. Rotate this, and I'll put the camera cable back in. Gotta be careful. Those are some very fine wires. I'll take the lens cap off, right? Because we want to see the video feed again. And we'll turn this on. And up as soon as I put my finger on the switch. Okay, turn it on. So now it's going to boot up. And as you can see now, there are a few small deviations that need to be corrected. But after that, I think we should be good to go. Ooh, I can hear the fan turn on. So we know the robot is on when we hear the beeping sound. And after that point, I should be able to log into it through the hotspot that it will broadcast. And then after that, we'll do the small deviation calibrations for this robot. So things seem to be moving forwards. You know, you got to be patient while the robot boots up. Okay, so it just booted up. It zeroed. This piece went down slightly. So I will log back into the robot. So I'm pulling up my Wi-Fi settings on my laptop at the moment. And I have to go and log back in to the Hiwonder hotspot. And it's got the HW- and alphanumeric character sequence after it, and the password is in all lowercase letters Hiwonder. So we're gonna log back in here. Now, probably don't want to touch it while it's on. That's not a good idea. I wish I had another camera that could show you that this right, it's slightly down. It's slightly downwards. It's slightly tilted downwards. Okay. So my computer has logged into my hotspot, and I'm pulling up Ultra VNC Viewer. So here it is. I'm using my save settings. I'm going to click Connect. Let me move these things. So Ultra VNC likes to come up on the screen where I'm not recording. All right. So view certificate. It's usually not best practice for security to do that, but for my purposes, I'm going to do this. I'm going to click OK. Username, Pi, password, Raspberry Pi. And now log in. And it pulled up the desktop on another screen, and then it just crashed. I'm not sure why. Not sure if it's a Windows issue, maybe a robots issue, or maybe it's an Ultra VNC Viewer issue. So let's try again, and I'm sure the audience is laughing at me. Okay, so let's come up, same authentication, Pi, Raspberry Pi, click the login. Okay, it looks like it's going to cooperate now. Okay, so here's the login. I've got the desktop up here, and as we did before, I'll open up two terminal windows, one after the other. So here's the first one, ls, cd, software, ls, cd, lab, _tool, ls, and we'll run the main.py program. And it's running. We'll connect. We'll connect to our camera. So now you can see the behind the scenes. So there's my gantry. Here's a box. Here's a lens cap. Whew. Yeah. Now you see behind the stage. So we'll put that here. And I'll open up another terminal window. And we'll do our minor calibrations. LS. Go into the software directory. LS. Go into the servo upper computer directory. LS. Run main.py. Boom. So here are the servo offsets. From my perspective, it looks like, okay, so let's do here. So we'll do that makes it go down, makes it go up. Looks like that's not quite where it needs to be. It's slightly out of calibration, even with the soft calibration. But I think you get the point here. Okay, let's do the other one. Let's do the other servo. That, just a little bit more. Let's see here. Just a little bit more. Okay. That is where it needs to be. Okay. So I'm going to save the offsets. All right. So let me show you something before I perform more calibrations on the camera module, the large deviation calibrations. Let's save the offsets. Okay, save the offsets. So it's saved in this YAML file. So I'm going to make it, call it offsets.yaml. One already exists from a previous attempt of mine. But I think for this video, maybe it'll be more thorough. We'll call this offsets video.yaml. Yet another markup language. So I'll click save. Should save. Now, let's verify that they get loaded. So I'm going to load the offsets. Or actually, I'm going to change one of these values to some other value other than what's set. Let's load the offsets. So offsets video.yaml, let's load it, and these get back to where they need to be. Now, actually, what I'm going to do is I'm going to set the servo 1 at 0. So that's at 0, right? So let's keep it there. And I'm going to save the offsets. Call this offsets video.yaml. We'll click save. Do you want to replace it? Yes, I do. So I've just replaced it. So servo 2 is where it needs to be. Servo 1 needs some adjustment. So again, exit cleanly from that terminal. Disconnect from here. Close this app. Quit. Yes. And it's thinking. Okay, it thought. And now we have access to the terminal again. So I'll click exit, or type in exit rather. Do that and close the desktop. So the desktop is closed. The next thing to do, turn off the robot. So the robot is off, and I'm going to put the lens cap back on and go through the step of delicately popping out that rivet and moving the camera module. It takes some finesse here, so put this here, pop that out. Okay, could use a little more depth here. It's actually, I thought it was hard for you to see. It's kind of difficult for me to see. It's black plastic on black anodized aluminum. So I'm gonna not pull that out. I'm sure the audience is laughing. Okay, let's use the tweezers again. Get the tweezers underneath it and push it like that. Okay, I got the entire rivet this time. So I'm going to take it and I'm going to put it here. All right, so now I'm going to move this off to the side. Now, it may be difficult for you to see at home. Sorry about that. All right. No, that's moving the servo. Hang on. Push this out. There it is. I think I've got it this time. Had to make that adjustment. Make sure that it's in alignment. I'll grab my trusty rivet again. And then the robot will have to boot up and we'll go back into the computer. That's an iterative process. Some people may get frustrated as they do it, but you know, it takes time to build up a skill, right? So pop, bam, rivets in there. Rivets where it needs to go. So put it back here, take the lens cap off, and turn the robot on. Now we go through the task of waiting for it to boot up. And while we're waiting for it to boot up, I'll pull up my Ultra VNC viewer and we'll get that ready. So you should be able to see my Ultra VNC viewer. Again, let's take a look at these options while we're waiting. So you see you can pick a variety of these options if we needed to, but we're just going to use the defaults. The defaults work very well for us as of now. There are other modes of operation. You can change the port, right? No, right now we're just using the default VNC port. Okay, so the robot successfully turned on. It beeped, and I do not see the servos did not move, and I think they may be very close to being calibrated. So now that the robot is on, it's broadcasting its Wi-Fi hotspot. And if you've been watching at home, you should know by now, it's of the hotspot SSID. The name of it is HW- an alphanumeric character sequence. So my computer is currently connecting to it. It's logging in. And as soon as it does, then I can use Ultra VNC to connect into the robot. So it's still connecting. Maybe there is an alignment issue on there, but that's fine. It's an iterative process. It's a learning process, and these things take time. Okay, so my hotspot is connected. So let's log in with VNC Viewer. So here we go. Username, Pi, password, Raspberry, Pi. Let's click log in. Okay, I think, yep, okay, so it just logged in and then the connection dropped. I'm not sure why that is. I'm not exactly sure what the bug is. Now maybe one of you in the audience, maybe someone's a genius here and you're very well familiar with these protocols and you would be able to find a bug or advise me as to why this is. So, hang on. Ultra VNC does not seem to be cooperating with me at the moment. And as this is happening, I'm sure the audience at home is laughing at me. All right, so let's click connect. All right, username, Pi, password, Raspberry Pi, login. Okay, so here's the robot again, and as we can see here, so looking from the top, maybe there could be an adjustment. So from my angle, the camera module is slightly pointed down, right? It's slightly down. So I recall from memory, it's in the software directory, lab tool, and we'll run main.py. And this will give us access to the camera images. Click connect, and there, we can see it. Oh, here's my hand. Hello. So I will move this off to the side. Open up another terminal window. Come on, double click. There we go. And then we'll go to the servo upper computer. And we'll run main.py. So we'll go in here. So you see they're all at 0, but what we'll do is we'll load the offsets. Offsets video.yaml. Oh, that was the wrong file. Sorry. Offsets video.yaml. Okay. So that looks to be where, from this angle, looks to be about correct. And now I'll change the camera tilt. Looks like that's where it needs to be. So I will save the offsets. Yes, I want to replace it. Thank you for asking. That's very kind of you, Raspberry Pi software. Okay, so that is the calibration, the large calibration and the small calibration of our camera modules. Now, perhaps you at home may do better, and I think I may link back to this, but again, if I was to do it again, I'd zero those servos with this servo tester that we get from the RC world, right? Zero those servos first before plugging them in, and then the cables are buried under the cable cover, right? Well, anyway, thank you for watching, and yeah, thank you. Hi, I'm Andrew, the Paisley Robot Guy, and if you like what you saw in that video, please hit the like and subscribe buttons below. I'd very much appreciate it. Thanks.